We're going to continue practicing graphing of exponential functions, but this time our b value is some fraction or decimal between 0 and 1. It's still going to be positive, but it's going to be less than 1. Same rules apply. We're going to make a table, plot the points, figure out the horizontal asymptote, and determine the domain and range. We have y equals 1/2 to the x. Since this value of b is a fraction, I'm going to focus more on x values that are negative. That way it'll become an integer. So I'm going to use x values of -2, -1, 0, and then I'll just put one positive in there just to see what happens. When I evaluate this at an x value of -2, I have 1/2 to the -2, which is the same as 2 squared, which is 4. Then 1/2 to the -1 is 2, 1/2 to the 0 is 1, and 1/2 to the 1 is 1/2, or 0.5. Plotting our points, we have -2 up, 1, 2, 3, 4. Then we have -1, 2, 0, 1, and 1, 1/2. We're not adding or subtracting anything at the end, so our horizontal asymptote is at y equal to 0. So we got to put that dashed line. Now notice this time, our graph is going in the opposite direction. Instead of starting really small on the left and getting really tall on the right, this time it's really tall on the left and really small on the right. So we're getting really close to our asymptote, and then if we're going in a leftward direction, it's getting really, really tall. So it's backwards from what we were doing if b was greater than 1. Domain is not changing, still all real numbers or -infinity to infinity. Range is also not changing in this situation. We're going from 0 upward to infinity. Y equals 1/2 to the x minus 1 plus 2. I'm going to use x values of -1, 0, 1, and 2. If I substitute -1, we have -1 minus 1, which is -2. So now we have 1/2 to the -2, which is 2 squared, which is 4. 4 plus 2 is 6. Substituting 0, 1/2 to the -1 is 2, plus 2 is 4. Substituting 1, 1/2 to the 0 is 1, plus 2 is 3. Substituting 2, 2 minus 1 is 1, so 1/2 to the 1 is 1/2, plus 2 is 2.5. And now we plot. -1, up, 1, 2, 3, 4, 5, 6. 0, 1, 2, 3, 4. 1, 3, 2, 2.5. Our horizontal asymptote is at y equal to 2. So at every y value of 2, we're putting that dashed line. And here's our graph. Getting really close to 2, but not actually touching it. Our domain, -infinity to infinity. Our range, the lowest this graph gets, it's getting really, really close to 2, and then it's going up forever. Final example, y equals -2 times 1/3 to the x plus 3. The x values I'm going to use are going to be -4, -3, -2. When I substitute those in, we have 1/3, -4 plus 3 is -1. 1/3 to the -1 is 3. So now we're at times -2 gets us -6. Substituting in -3, our exponent becomes 0. 1/3 to the 0 is 1, times -2 is -2. Substituting -2, that gives us an exponent of 1, so then we're left with -2 over 3, or -0.6667. Plotting those points, we have -4, -6, it's going off the graph a little bit, -3, -2, and -2, -2/3, which is almost -1. Not adding or subtracting anything at the end, so we have a horizontal asymptote at y equal to 0. And here's our graph. Our domain, still all real numbers. This time we have an arrow pointing downward, so our range is starting at -infinity, and the highest that it gets is close to 0.